Hello, Marcel.
Hi, Alessandra.
How are you doing?
Fine. Downloaded already all the files you brought, but what are you doing?
Great. So I went for a trip, and it was a good occasion to actually do a journey throughout facade design, engineering, throughout history. Let's start from Rome. I want to show you something.
Rome, okay.
This is it's a video of the Tabularium, a building in the Fori Romani, one of the first time in the center of Rome. The arch is used in the facade to open large openings. The first type of facades, as you remember, are solid walls. The fenestration openings are very small because of the tectonics of the facade and needs to sustain the load bearing, but the use of the arch enabled already at the Roman times to open large openings. If now we think about large windows and fenestration, which is maybe the next good example after this, we just go to the Middle Age or early Renaissance, Westminster in London.
Ah, okay.
I want to show you this because it's a very good example of how the use of the arch in the facade solved the safety and the tectonics in order to enable again large openings, which then have been fulfilled with large glazed
I can
surfaces.
see here from the inside how bright it is, how much light comes into that room.
Yeah, the use of stained glass, no, from the first times in the actually integrated in the facade enabled this, but also here the structural understanding of the tectonics is even pushed further. It's not only the use of the arch, but really the redirection of tectonics and stresses out of the facade, outside in this external structure that we see here, that is taking the load bearing outside the building and therefore opening such large windows. And I think this has been a bit of more or less the main trends with different aesthetics, climate control technologies, shadings, systems, construction and materials at hand that vary with local conditions, locations and country, but it stays more or less the same. And I think the next big leap we need to wait the 20th century or end of 19th century. Give you just an example. If we look at Gaudí in Barcelona,
Here. This is a crazy building.
Crazy building, a bit not conventional, let's say, but I just want to show you that this is a very good example of how incredibly a facade engineer could open, like Gaudí, large openings by using sandstone, the material at hand, and enabling a large surface that then is just for climate control, a timber frame and stained glass.
So you can really see the separation of the load-bearing parts, that is the sandstone, and the wooden facade. It's a big window or something like that, or a facade, and the stained glass here. Wonderful.
Still not a curtain wall, but towards that leap. Then, of course, if you think about this transition between facades that are load-bearing to the actual modern curtain wall, took some time. There are some very good examples of transition. The Witte House in Rotterdam.
In Rotterdam, we've been here together precisely. So, following a little bit the overall aesthetics from the Sullivan's building, Chicago school, high rises, but in this case it was a little bit mimicking, it was still load bearing. Huh?
Let's have a look. Did you know that Rotterdam also had its own White House, the Witte House? Actually, the reason why we are here is because this building is the first high-rise of all Europe, and also has an interesting facade. So we are at the transition time between the brick wall systems, typologies, towards the modern curtain wall, 1897. As you can see from the image, this building resembles Sullivan buildings in Chicago, one of the first examples of non-load-bearing masonry walls in high-rise buildings. The Witte House, instead, as an example of a transition time, is still a load-bearing brick wall. So even if the window frames and other details and products are in iron, the main wall is still load-bearing and is in masonry. So same typology, but different technology.
Yeah, that was a nice one.
And then Chicago School, the modern curtain wall, thanks to two main advances, by the use of new materials. They started already with Art Nouveau modernism, steel, cast iron, and glass in a much more performing manner. but also technological understanding of a frame as a structural system enabled the invention of the so-called curtain wall, a facade that is hung on the main structure, non-load bearing, of course still bearing the wind loads or the own weight, but everything else is burdened by the main structure of the building.
Just a note, in general, within all of our courses and books, we don't mention curtain walls so often because it's such a vague, overarching name. Nowadays, the technology has to be so further developed that we have more types underneath the main topic of a curtain wall.
So what you're saying is that curtain wall is a very big family
Yeah,
that
precisely.
started at the beginning of the 20th century, but now we can have a look and we will see the main typologies of
Like a stick facade, like
unitized.
unitized facades, and so on, and other claddings, for instance.
Two main things to remember: the starting of the curtain wall also enabled the start of maximum transparency, because then the load bearing performance was completely left over, but only in theory the climate control was left in terms of performance of the facade. At the beginning, when the curtain wall was developed, the push for maximum transparency, as we see in the pavilion from Mies van der Rohe.
We have it over here, for instance. Yeah, of course.
So here it's a pavilion, it's a special building, so of course it's true that requirements for climate control are much lower, but however this really shows the facade becomes a very large piece of glass, and this of course enable a completely different aesthetic and image, but also many problems in terms of sustainability and climate control. Nowadays, modern curtain walls, whether they are unitized or stick systems, are much more performing. Let's have a stroll in London city. The city of London, I think, is a great example of modern glass facades,
Oh, yeah, of course.
unitized, like for instance at the Gherkin, the building from Norman Foster. This is a very good example because technologically is much more advanced. The double glazing unit, the performance of the glazing itself with coatings is very developed, and this enables a much better climate control. Very clearly you can see these are units, prefab units, that come on site to be only hung on the primary structure and close the envelope. So this is a very good example of modern facade. If we look at the Shard instead, at the ground floor, it's a very good example of stick system because large span, flexibility in design and geometry, of course favor a use of a stick system which is much more flexible because it's all designed to be built on site.
Yeah, it's also often within office buildings, the first one or two floors have a different function, and then the office starts stacking, and this is then more standardized, and therefore floor to floor unitized facade elements are more common.
It can be prefabricated very easily. If we push prefabrication even further, we can have examples like the Erasmus MC in Rotterdam.
We've been there together. Let me see. Yeah, here we go. Ah, yeah, of course.
So here it's a very good example of a unit facade that is hung on the primary structure. So it's still a non-load bearing facade, but integrates many functions from ventilation to the window system. And this, of course, opens the floor following the example of Jean Prouvé. No, this is a very good example of his legacy in integrating many functionalities in one complete unit.
Actually, a side note, the company from Jean Prouvé produced these panels.
Interesting. Recently, advances in prefabrication and precast technology started again to bring into the market units, prefab units, which are not curtain wall because they are load bearing and they are made of precast concrete. A good example of a tall building that uses this technology is the tower in Rotterdam, in front of the central station. Here is still unitized panels, we can see them.
So what we see is the load-bearing structure.
It's a load bearing facade because it's precast concrete, it's produced off-site, it gets assembled on site, creates a very fast construction process. They are all built, and then the horizontal slabs are then buried by the facade itself. So this is also a bit of a shift that we are seeing now.
Means also you can't easily take off the facade because it's part of the load-bearing structure.
Very true, and also,
Okay.
of course, not the most sustainable use of materials because it relies heavily on concrete.
Where does it end? What's the last step?
So I think what we are already seeing in the market now is developments in the design and construction in terms of parametric design that allow to customize and optimize different parts of the building depending on the orientation and the functionalities in a much more precise and optimal manner.
Mm-hmm.
Good example, the headquarters buildings of Bloomberg in London.
Oh, I found something here from you already. Okay.
Again,
That's an
a
interesting
design
building.
from Foster, a very interesting facade because it's thanks to digital parametric design, is customized to have the optimal geometry in terms of the shading and the window to wall ratio to respond to the solar gains and the light requirements depending on the orientation.
So that means these big flaps on the facade, they are static and they are designed parametrically according to the influences of the sun direction and so forth.
This is why each orientation is a different facade image.
Yeah.
So this is a very good understanding of how we can then efficiently achieve high performance on all these: construction, material, safety, climate control and aesthetics with one facade solution.
And it all started in Rome.
All started in Rome.
Impressive overview and a very personal story about the history of facades. Thanks.
Key concept in a nutshell. Now time to go in depth with the materials we developed, the readers and the lectures from Professor Nack. So, thank you for listening to me.
It was a pleasure.